now we're going to do example 3 with the chain rule. We're going to get it a little bit sassier, all right? So we're going to combine product rule with chain rule. That is a good time. All right, so let's look at this problem here. So first thing first, we have something in parentheses being taken to exponents. That means I'm going to have to use chain rule there. The other thing that's going on is we have the product of a first expression times a second expression, and that we have to use product rule. So we're going to combine these two rules. All right, so remember, product rule is the derivative of the first expression times the second plus derivative of the second times the first. Okay, so here we go. Derivative of the first. So this is our first expression. When I do the derivative, that 5 comes forward, and I get 5 times. Don't change what's in the parentheses. Subtract 1 from your exponent, and you get to the fourth. Chain rule here. Remember, chain rule says you now have to do times the derivative of what's inside. X to the first. When I take the derivative, just becomes 1. I bring that 1 forward. I subtract 1 from my exponent, and that gives me 0 x's left, so I don't even write them. And then I get 2x when I do the derivative of x squared. Okay, all of that is the derivative of the first expression. Okay. Sometimes people try to do chain rule and keep on going. Sometimes people try to multiply times the derivative of that. You don't just keep doing derivatives of parentheses, okay? That in the blue parentheses is the derivative of what's inside, and that's all you do. You don't keep going there. Okay, that's the derivative of the first. I got to multiply that times the second expression. Not the derivative, but just the second expression. So my second expression is right here, and so I've got that as 1 plus x cubed squared. Okay, so that's the second. So that's the first half of my product rule. That's just this part right here, derivative of the first times the second. I've got to add that to plus, so I got a big giant plus sign. Now let's do it again. Only now we do derivative of the second expression. All right. So that gives me 2, because I bring that exponent forward. 2 times 1 plus x cubed. Subtract 1 from my exponent, and I get to the first power. Now I've got my chain rule times the derivative of what's inside. The derivative of 1 is 0. The derivative of x cubed is 3x squared. Okay, all that is the derivative of my second expression. Now I multiply times the first, which is x plus x squared to the fifth. Okay, so I've checked my formula. I have all pieces of my formula here. Now you got lots of simplifying that you're going to do. So let's scoot this up. Sometimes this is the hardest part for people, is knowing what you can combine, what you can't combine. First thing let's talk about is we've got exponents here. We have parentheses with exponents. Always remember, you can never multiply into parentheses where there is an exponent. Okay, you can't do it because the order of operations says you got to do the exponent first. You can't multiply first. So never allow yourself to do that. But this is kind of like when we were doing the rule of conjugates with our limits. We said, you know, don't necessarily multiply everything out because you might miss common factors. And so we're going to keep that rule here. So to simplify, if you have terms that, okay, like we do have here in the second expression. I have a 2, just the number 2, and then I have a 3x squared. In this parentheses right here, there's no addition and subtraction. That's just 3x squared. So you can simplify that by combining those two. Go ahead and multiply those two. It's 2 times 3x squared gives you 6x squared. And then go ahead and write your parentheses, 1 plus x cubed to the first. And then you have x plus x squared to the fifth. That's your second expression. Oh, man, I should have written it. I'm going to erase this. I probably should stop the video and edit, but I don't feel like doing it. Dadgummit, you're not the bosses of me. All right, I'm going to start back over with the first one. This 5, I'm going to put my parentheses in order of their exponents. So I'm going to put the 1 plus 2x to the first, and then the 1 plus x cubed squared, and then the x plus x squared to the fourth next. Now, the only, squared, there we go. The only option for simplifying that you might do is you could distribute that 5 into the first set of parentheses because the exponent is 1. But that's the only thing you could do, and I don't necessarily recommend it because if you had a common factor next, you wouldn't be able to see it if you distributed the 5. So just leave those off to the side there. Now let's do that next grouping. On there, this is the part that I was talking about. Because you have a 2 and a 6x squared, and that parentheses, you have no addition and subtraction, go ahead and multiply those two and get 6x squared. And then, again, put your parentheses in order of their exponents. So that's what you get, that whole expression right there. Now let's talk about checking your answers in the back of the book, which you have got to be doing while you're doing homework. You may do a problem and the answer in the back of the book doesn't look the same. There's things you need to know, things you need to check for. Because you might have the same answer, it's just in a different format. So number 1, check for factoring. Check to see, did the book do things like, one thing you could do is they might have distributed a 5 into parentheses. Now, here's a common error. You can't make this error. Sometimes people think if you have a 5 in front like this, that you distribute 5 everywhere. No, that would be like multiplying by 125, by 3 5s. It's just 5 times whichever one of these you want. Okay, again, in simplified terms, that would be like if I'm multiplying these 4 numbers together, that doesn't mean 5 times 2, 5 times 3, 5 times 1. It just means I have 1 5. And whether you combine these two first and get 10 times 3 times 1, or you combine 5 times 3 and get 15 times 2 times 1, it doesn't matter the order, but you do only do 5 times one of those when you're simplifying. Okay, that's just a little side note. All right, so check for factoring. Check to see if you're checking your answers in the back of the book. Did they recognize things like they both have a parentheses that says 1 plus x cubed? And sometimes they will factor that out and put it all the way to the beginning. Same thing here. I have x plus x squared to the fourth. This one I have x plus x squared to the fifth. They may factor out the x plus x squared to the fourth and put that all the way in the beginning. And then with what's left, they might simplify. So I'm going to show you what that would look like. But I don't want you to get freaked out. I mean, we're done with the problem. The calculus is done. In fact, some of you probably have already stopped the video, which would be a shame because you're going to check your answers and you won't be able to tell. So let's say the book factored out, all right? So they have a 1 plus x cubed to the first in common, so I'm going to factor it out. They also have an x plus x squared to the fourth in common. They both have at least 4 of those. So I could factor those two things out. With what's left in the first, I still have the 5. I still have the 1 plus 2x. I took out 1 of the 1 plus x cubed, but I still have 1 left. But I took out all of the x plus x squared to the fourth. I took out all 4 of those, so there's none of those left. Okay, now let's go to the second expression. I still have 6x squared. 6x squared. I don't have that 1 plus x cubed because I took it out. But I do have one of these left because I only took out 4 of them. So I have x plus x squared left inside. Okay, and now what the book would do. Notice I don't have any exponents anymore with my parentheses. So because of that, you can multiply all these together. Do we have to do this? We have to do it, don't we? So, again, just do 1 5. So it'd be 5 plus 10x in parentheses times 1 plus x cubed. So I'd have to do that next. This one's easier because I just distributed 6x squared in there. So that's 6x cubed plus 6x to the fourth. Now I got to multiply 5 plus 5x cubed plus 10x plus 10x to the fourth. That's just your FOIL. 5 times 1, 5 times x cubed. 10x times 1 and 10x times that. Plus 6x cubed plus 6x to the fourth. Now all that is in brackets. Combine your like terms. What do I got? I got 2x to the fourths when I add those together. Oh, you know what? Okay, let me write. I'm going to bring down these parentheses. So here's my grand answer here. I got that. I got that. X squared. Okay, and then here's that's a big old 2. Here's what's going to be left in the brackets here, parentheses. I have 10x to the fourth and 6x to the fourth. That's 16x to the fourth. I have 5x cubed and 6x cubed. So that's 11x cubed. And then I have a 10x, and then I have a 5. Okay, and the order of those 3 parentheses doesn't matter. In fact, it probably would come second. They might multiply those two together. I don't know. But as you notice, that looks vastly different than the answer that we had up above, that circled answer. I mean, it looks really different. So I don't want a student to look at the answer in the back of the book and have it be this, and then look at their answer and go, well, I don't get it. I don't understand what's going on. So always check to see, did the book factor something out? It's highly likely that they did. And so you might get the answer. If you're dealing with fractions, they might have gotten a common denominator. So if you have an answer with 2 fractions, and you check the back of the book and it's just got one kooky looking fraction, they might have gotten a common denominator. So check for that.